Alright, you guys see the positive, right? So will alternating work? No. But we have tests for alternating. A sub n is a series that has positive terms. I have a ratio test and a root test. And why are they all in one Endeavor card? Because they're similar. See, they have the same conclusions, just you take different limits. For ratio test, you take limit of nth plus 1th term over nth term. And for root tests, you take the nth root. What is this now? Endeavor number 20? Is it still 20?
25.
25? Okay. Chelsea's getting your tests up there. She's up to the direct comparison. So she needs, what comes after direct comparison? Limit comparison?
Yeah.
Absolute, no, alternating series test, absolute conditional convergence, estimation, remainder theorem, right? Yeah.
When yesterday I was absent,
Yeah.
so you have a new
Yeah, I
Endeavor
think
cards?
Yeah, the estimation remainder. We had one. It's this one right here. You'll see it online if you look.
Okay, I'll see it online.
This one.
Yeah, okay.
I think, did I label? Ooh, I did label right here.
Okay.
Sorry, I should circle though.
Something
There.
sticky. This is what I want to tell you.
Okay, guys, you can tell the ratio and root test, we're taking limits, right? Limits to infinity, and sometimes limits are easier. What conclusions can we make? Okay, first conclusion. We're looking at the limit, and we're assuming that it equals a constant. Okay? If L is less than 1, how could it be less than 1? Will it be negatives if it has positive terms?
So like fractions.
Like fractions, like 1/2 or 3/4 or 0.1, right? So those kinds. If limit is less than 1, can't be negative because only has positive terms, can't be 0 because no negative terms. So if the limit is less than 1 but technically greater than 0, right? Then the series converges. If the limit is greater than 1, so like 2 or 5 or 10 or 23, right? Then the series diverges. If the limit equals 1, you know nothing. So for the ratio and root, we don't want it to equal 1. How important is the Endeavor quiz going to be on Monday to your success on Tuesday? Extremely. We didn't know our test perfectly for the first time, 9-1 to 9-3, and now we have how many more? Few more, right?
No, 4.
Let me double check my number. So we have geometric, we have nth term, we have p-series, we have integral, we have direct comparison, we have limit comparison, we have alternating series, we have, 9 tests, ratio and root, but they're kind of one, sort of one. Really quick hint, which I don't know if it's something to memorize, but it is something to definitely know. And Melissa, you'll like this. Ratio test, you can use it when there are factorials or nth powers. Root test can also be for nth powers. So the ratio test is really nice for factorials or nth powers, and then the root test is nice for nth powers as well. So helpful with factorials or nth powers. I know I'm kind of hitting that home. Layla.
When you mean nth powers, you're not talking about like the p-series ones, are you?
No, not the p-series one. Not the p-series one. Like when n is in the power. Because p-series, it's n to the p. But what if you have like 3 to the n?
Okay.
Does that make sense?
Yeah.
Yeah. Ready for examples? Oh, are we still writing? Tests are important if we're still writing, but take a little bit longer. Hold on. I said it wrong. Could equal 0. Could equal 0, but not negative. Shouldn't be a negative. Could equal 0 though. Here we go. Now, before we might have done direct comparison, right? Direct comparison, compare it to what? 1 over n squared maybe?
Yeah.
But what does well, hold on. Which one is really nice for factorials?
Oh, we should
Ratio test. Remember guys, I want you to be in a habit of choosing a test. Now, sometimes you might try different tests, but you have to show me which test you choose, even on the test on Tuesday or the practice test. Choose a test and tell me which one. Some of you lost points last time. Show me the test. Okay, ratio test. What does it say? Positive terms? Guys, are these positive? I have 1, I have 1/2, right? I have 1/6. Positive, I'm good. That's the only condition, right? That's the only if. If positive, good, done. Ratio test. What does it tell me to do? I take the limit as n goes to infinity of what? What's on top?
1 over n plus 1.
All over? Because it's the a sub n plus 1 over the a sub n. So I take the nth term, and then I put in n plus 1. Why did we practice factorials? How do you simplify? Well, I can rewrite this because reciprocals, right? Isn't it same thing as n factorial over n plus 1 factorial? Good. It's n factorial over n plus 1 factorial. How do I simplify that?
1 over n, n plus 1. You cancel that.
Yeah, you cancel.
Wait, pause. Does that make sense? Because I go 1, 2, 3 all the way up to n, and then what would the next one? 1, 2, 3 all the way to n, but I go 1 more, n plus 1. So 1, 2, 3 all the way to n, 1, 2, 3 all the way to n. Those cancel, but I get n plus 1 still. Does that make sense? Why is this so good? Wait, limit equals,
0.
which is less than 1. So,
Conversion.
how easy was that? Does that make sense? Look at your endeavor card. If the limit is less than 1. Series conversions. The limit is less than 1. So even though we saw how to do with factorials with direct comparison, limit comparison, okay, we saw how to do it. But ratio tests can be so much nicer. Layla,
Can you use this with like anything? Or
as long as it has positive terms.
cool.
I know, right? It's a nice one. Because you're not, why is it so nice? Because you're not making up something. It's not comparison. Comparison has its place, but this one you just go n plus 1. N plus 1th term. Okay, how about number 2? What do you think? Root test or ratio test?
Ratio.
Want to try ratio? Okay. If we try ratio test. First of all, positive? Yeah, 1 over 2 to the 1, 2 over 2 to the 2. Yeah, good. Positive. Okay. Ratio test. Limit as n goes to infinity of n plus 1 over 2 to the n plus 1 all over n over 2 to the n. Ugh. Let me give you guys a second. Why don't you keep going? Let's see how far you can simplify. If you can't simplify, it's not going to matter. How far can you simplify? Which one's greater? Why? How was I able to simplify? Because this is so helpful, but how? What does 2 to the n plus 1 equal?
2 times 2 to the n.
remember, adding exponents means there was another multiplication. So then I was able to simplify. So then I can say n plus 1 over 2n equals 1/2. 1/2 is less than 1. Right? Therefore. Now I actually want to do this one. Oh, stuck. It's okay. I want to do this one another way too, because we haven't seen the root test, and this next one should be a ratio test because it has a factorial. So let me show you how the root test works. Usually ratio test is nicer, so then you're going to use that one more.
So Misty, how do you judge its ratio or root?
Yeah, that's what I want to show.
I think you try ratio first, and then if ratio doesn't work.
Yeah, that's what I would do. Ratio is usually easier. So it's the same problem. But how would it work? Same problem, yeah. Actually, I did this one originally with the root test. So let's see how the root test works. Root test, what is the difference? Positive, still positive, good. Limit as n goes to infinity. What do? I take the nth term, and what do I raise it to? 1 over nth power. Yeah, so then I can do right? Because I can raise 1 over nth, 1 over nth, not adding, not subtracting, dividing, legal. And then 1 over n, and then 2 to the n times 1 over n, so it goes away. And then remember what we did yesterday? Limit as n goes to infinity. What is this approaching? 0, right?
So it's 1. Oh, yeah.
So it's 1 over 2. Also.
Yeah.
I forgot this.
Yeah.
So it's infinity to 0.
Mm-hmm. Now, sadly, I'm going to play devil's advocate because
The special.
I'm looking at indeterminate forms really quickly. I want to make sure I'm not doing anything illegal.
I think it's special
I think
sequence.
Yeah, special. No.
Oh, that's what it is. Yeah. So I shouldn't show it this way. Thank you. I shouldn't show it this way. I was going to say, the way I'm doing it is illegal because infinity to 0 does not necessarily equal 1. But if we go to special sequences, the limit as n goes to infinity of n to the 1 over n goes to 1, right? I'm double checking. My way was illegal. I thought it was illegal. I just had it. Where'd it go? Here it is. Yeah. The limit as n goes to infinity of the nth root of n is 1. Good.
Yeah.
Good. Special limits. So then 1/2 less than 1, and we say, oh, okay, same thing. 1/2 less than 1, therefore series converges. But do you see, 1 over n would have no meaning if I wasn't undoing something. So 1 over n undoes. Now, on this one, it was like, okay, this has n, this one doesn't, so that's why ratio test worked just as well. It worked fine. But root test, if you have like 2 to the n, now sometimes you can do geometric, but if you have 2 pieces, I can't do geometric. Geometric works with 1 over 2 to the n, but not the other way. How about this one? ratio or root?
You say ratio.
I say ratio. Now, it might be because you think ratio is easier, but also factorial. And ratio is great for factorial. So we can think of ratio, right? Ratio exclamation point. There we go. We can start screaming it and then we'll remember. Ratio for factorial. There's root, and there's ratio. There we go. What Shakespeare play is Horatio? There's a quote with Horatio.
That is really simple.
Is it Horatio?
I feel like it's a no one too.
Horatio.
Isn't it Hamlet?
Hamlet?
Hamlet.
Is it with Horatio?
Hamlet definitely has Horatio.
What's
I feel
the
like
quote with
he uses
Horatio?
that name
I'm
a lot
curious.
though.
Yeah, I feel like, yeah, that's what I was thinking.
It's a universal Shakespeare name.
He just likes the name Horatio.
I'm gonna name my son Horatio.
I thought you were gonna name your son like some Jordanian
Ew.
or Arabic.
No,
I know that's sobbing. She wants to name her kid something Arabian.
Oh, last point you are right. New Horatio. That's the one I was thinking of. But there's also what's the other one that has
Hamlet.
Hamlet.
There are more things in heaven.
And
There are more things in heaven and earth, Horatio, than are dreamt of in your philosophy.
I don't like Shakespeare.
I thought it was you, right?
you don't?
I knew him, Horatio. Anyway, sorry. Distraction. You guys doing ratio test?
Yes.
So you have to raise it wherever the n is. I mean, you have to add wherever.
Because it's like function notation f of x. I have to do of n plus 1.
Is it one? So also.
Is limit 1? Hold on. You beat me. I didn't get there yet. Let's see. Go ahead, Mandy. What's the question?
Yeah, the question is, if you make the n plus one, so the power also make n plus one.
Mm-hmm. Because it's like function notation. So it's n plus 1, n plus 1, n plus 1. Yeah. Does that make sense?
Yeah. And then how to? Is that one? And then those cancel out. And then just
Right.
like ratios, right? Yeah. So we know nothing.
We don't know nothing. Can you figure out what to do? It's not know nothing. It's not 1.
Could you do 1 plus 1 over?
Melissa.
And use root.
Melissa, Melissa, Melissa.
She's a smart cookie.
Oh. Oh yeah.
Oh yeah, that's so.
Oh,
right.
that endeavor card is important.
That's right.
N plus 1 over n to the nth, I can make it 1. N over n plus 1 over n. 1 plus 1 over n to the nth equals e. And e is
Not equal.
greater than 1. So therefore, series. Nice.
Smart cookie.
That one's tricky.
Ooh. That one was interesting, not tricky.
Yeah, interesting.
It was tricky.
Oh, that's no fun.
Even vetoes.
How about let me show this one first.
This one will just show
Let me show you a couple different ones. Let's do this one. How'd you do on this one? I'm gonna see if I can find it on no one. Hold on.
Can you show 29?
Hold on. I'll look at it though.
Because the book said we need to use ratio test.
Root test didn't work.
Root text does work, but
Oh, but ratio doesn't?
I think ratio also work, but it is a kind of like that question. The one before.
Just trying to find one that equals one. Ah, here we go. I found one. How far did I go on the last page? 1, 2, 3. This could be like 4. For this one? What happens when you try ratio test? You want to try root test instead?
No,
I gotta know.
ratio test.
You
The
can
ratio test
change
works.
4n squared minus 1 to 2n plus 1 times 2n.
Can't do plus 1. 2n plus 1. Illegal. Because I can't take square root of binomial.
No, I change it to 2n plus 1 and 2 times 2n minus 1.
Oh, to simplify.
Yeah, you can simplify that.
Yeah.
Okay.
How many of you guys started ratio test though?
It works.
I'll do majority. But yeah, root should be the same. Limit as n goes to infinity of. What'd you guys get?
I got 2.
Sure.
Then you have 2, because 2 to the n, 2.
Little. Just algebra.
Then if you were to do it, you would get 4n squared plus 8n
Whatever.
plus 3. What would you get? 8 over 4.
2.
But what else could you have done? Series diverges, right? We know that. But is there another way? Did you get diverges for yours too, Mandy?
I didn't go through it. I just crossed it.
Oh, no. But guys, what else could you have done? just a reminder, you could have just done that way. Either way. Either way.
Alternating test.
How about this one? Alternating test? Why am I doing it here then in ratio and root test?
Because ratio test is equal to 1.
Yes. I'm trying to show you, if you like the ratio test, you might be like, hey, test for absolute convergence, right? And absolute convergence, I think absolute values. So if I'm considering the absolute value, I would consider and once you like the ratio test, you might try to do the ratio test with the absolute value. So then ratio test, limit as n goes to infinity, you get square root of n plus 1 all over n plus 1 plus 1 n plus 2 times, flip it, square root of n over n plus 1. What's the limit? Well, I have n root n and n root n, right?
Yeah.
Limit equals 1. This is an example of I know nothing from my ratio test. Now some of you were like, but no factorial, no nth power. Why would you do ratio test? Okay, I wouldn't do ratio test either. What test would you do to figure this one out? Alternating series test. But I have to think about, because limit of the term is 0, right? So I have to think about absolute value. How would I do absolute value? Limit comparison? What would you compare to? Remember how we look at polynomials and we think about what degree is? What's the degree? N to the 1/2, n to the 1. It's kind of like 1 over n to the 1/2, right? Right? So couldn't I maybe do? Direct comparison, I have to think of greater than, less than, equal, gross. Let's try limit comparison. Compare to do you see how I chose? Look at degrees. Limit comparison, I take limit as n goes to infinity of, which way does it go? The one that's given over the one I choose, or the one I choose over the one that's given? The one that I choose goes, what goes on top? I have a sub k and b sub k, a sub k over b sub k. I think it's the real one, right? Over the chosen one. I know. I'm actually asking you guys because I don't remember. Hold on.
I think it's actually we can use square root n over n to compare this, because L is equal to 1.
But square root n over n is 1 over root n, right? Same thing?
Yeah.
Huh. I was going to say same thing. Because then L is equal to 1. What is limit comparison? We don't remember that one very well, do we? Because you guys aren't saying anything.
And then both converge or diverge.
Limit comparison. The one I'm given over the one I choose. And then if the limit equals 1, which is greater than 0, both converge or both diverge. Oh, wait, I just need to do this. Taking too long. There we go. What I compare to? 1 over root n, which is greater than 0. This one, wait. 1 over n to the 1/2 diverges by? since p equals 1/2. Good, Youngji, so yeah, diverges. Because since limit is greater than 0, then I can say series diverges. But what was I talking about all this time? I was talking about absolute value, right? So then diverges. Okay, Melissa, what do I have to check on next? It's the one that you like to start with. We started with the absolute value, but you like to start with alternating. Yeah, alternating series test. So we have to do alternating series test.
You see, do we have to do the absolute, or if we use
This one says diverges, so could be conditionally, right? Because remember, if absolute value diverges, this could still converge, so then conditionally convergent. Yeah. So then limit as n goes to infinity of, was it root n over n plus 1? Right? Yeah, equals 0. Check. And then a sub n plus 1 equals square root of n plus 1 over n plus 1. Uh-oh, how do we compare? This is, I think, Youngji, you and I did this one. This must have been in homework or something for limit comparison, because I remember this problem. How do we compare? Well, his denominator is a little bit bigger. Yeah, but his numerator is a little bit bigger. Uh-oh. You can think of a couple things. One, how much bigger is his numerator? 1 whole 1 bigger, right? How much bigger is his numerator? Not 1 whole 1, because it's under a square root, right? So you could think, okay, so it's bigger than by whole 1 and then bigger by than less than 1. So you can think denominator is stronger still, so since denominator is stronger, I could say less than. If you don't like it though, what could you do? Write some terms and then write in your calculator. You could write some terms and then write in your calculator. I think like for n equals 1, 1 over 2, root 2 over 3. I don't remember if this one worked right away or not. We have a little bit of time. Does anybody want to get out the calculator and check? I'm getting mine out to check.
I think because the border is always bigger than top, so it and increase.
Yeah, in degrees, that's what I was thinking, because the plus 1 on top is smaller than the plus 1 on bottom, because under the square root. But I know some of you guys won't like that. Won't like that rationale. It's not very precise. So now I was just going to go ahead and test and make sure that it wasn't one of those like it works sometimes and not other times. So then, if I plug in 1 for this one, I get root 2 over 3. So that's on the left-hand side, and then on the right-hand side, 1/2. Well, yeah, this one's smaller than 1/2, right? If I was to keep going, it looks good so far. If I was to do root 3 over 4, you keep checking. Plugging in 2 root 2 over 3. And some of you would just be able to look at it and see, but you can keep on seeing it's going to be smaller, it's going to be smaller. As we keep on going, it's going to be smaller. So it's true, it's just a harder one to tell. So therefore, what's my series? Whoops. Series is, because this is check, right? Yeah, absolute value diverges, but alternating series converges. Oh, I can't talk, so therefore series is conditionally, right? Convergent. Kiddos, I'm done. I know Ethan had a question, but I think just root test. I don't think it's hard, right? Number 27.
But they asked me to use ratio.
Oh, if they? Oh, they said you had to?
Yeah.
I don't know. Okay, I'll do number 27, but if you guys want, you can get out paper and you can start working on homework. Here's homework. Nope, that's not homework. Here's homework. There's homework.
It's 29. This is 29.
29, not 27? Okay.
Not 27.
because remember their homework, like you're learning how to integrate, so then we have to take a couple of days on integrals, or learning how to do like trapezoids and rectangles and Riemann sums, that took a couple of days. So like they have lessons that take 2 or 3 days, whereas our lessons are 1 or 2.
Oh, so
Same with pre-cal. Pre-cal is usually like 1 or 2 days, but AB is sometimes 2 or 3 days. So then they take, or I do like AP assignments. How do you do an FRQ? How do you know what I mean? Whereas you guys don't need to know.
so I don't remember yet. Last year we
Uh-huh.
prepared for AP test. So like
Yeah, you guys didn't like writing
year
explanations. You
we
still
do
don't
the-
like writing
We do the
explanations.
passing.
I know you like
so
multiple
the
choice.
this year
If you
the
would
same
wear
after the
90s, I'm just
brain
curious.
break we have.
We had school uniforms. I pretty much just like lived in that. Huh?
Obviously, so this year the same we have a mock test during spring break.
April 18th.
Wait, can I
April
take a picture of the
18th.
assignment really quick? Sorry.
Huh?
Can I take a picture of the
Oh,
assignment?
yeah. Take a picture of the assignment if you need to, because I want to work on Ethan's question, which was number 29.
Why did you so early this
The 90s, what did I have? I had overalls, I
That
had
is early, huh?
overalls, sweatshirts, t-shirts. I was just,
T-shirts, what?
I wasn't that excited for the 90s. I was also a little kid. For the most of it.
Oh, we're still talking about it. I didn't know we have it.
I was actually thinking what I did wear in the 90s.
Oh, you did too early.
And my school, you had to wear skirts every day, so then I was just like in skirt, like a khaki skirt and a jean skirt and like a t-shirt. Yeah, it was not a huge fashion statement. Weren't doing minis.
No, so we were 5 when we graduated high school.
That's so weird.
Aw, you were little kindergartners.
Are you little babies?
When I was finishing, you were starting. Here we started at the same time, because you guys were 6, 7. No, you guys were 6th, right?
Yeah, you're
Yeah, you were the first 6th grade class, and it was my first year. Aw, little baby.
So this is homework number 48?
Homework number 48.
Get up.
Where are we, Ethan? 9-6. Huh, I can't even figure out what page we're on. All right, number 29, right? You guys can keep going. I'm just gonna do number 29 because Ethan was asking about it.
No, I just have
What'd you
one
do?
question.
Oh, what do you have a question?
Does
Is it
A
not hard?
equal to 0? This one. This one. I think it does because the bottom is 1 more.
1 degree higher.
Yeah, 1 more.
This is bad. This sounds like a uniform.
Well, and if I take it
It's
off,
weird.
you'll see both.
Yeah, it should be 0.
So
I would show it. I would show it.
So I
I
have
would
no
show why.
question though.
I would show why. Well, it's a good one to show them though, as to why it's true. As to why it's true. Like how you can prove it. You know what I mean?
Actually a good
Yeah.
one.
Because in your head you can say, oh, okay, but
That one made me.
they might want to see why. An octopus. Oh, Melissa, are we making a new joke?
It's not a very good one. Have we unassigned practice problems for 9.4 and 9.5 yet? For this assignment?
Don't worry for him. Or don't worry about him. So you're gonna get the practice test tomorrow anyway, you know what I mean? So, yeah. Don't worry, we'll just leave those off. Guys, don't worry about the blank, because we'll just leave it off.
I love that.
Oh no, they said ratio test, huh? That was the whole point. They said you had to do ratio test.
The test is very easy.
Yeah, root test is very easy. We might look at this tomorrow. I don't think you guys need me to do it right now, though.
I don't think
We'll see. We'll see how you guys do with your limits. Be careful of directions. Some of the directions they like tell you to do a certain